So this is the section that we're on. All right, your questions for these problems, have them ready for me. Now, for those of you that are getting this work done, you're going home, you're taking the time to do this, you are going to be the ones that when you take this quiz, you're going to do fine. But if you know that you're going home and you're not getting any of this extra work done, I'm not giving you guys homework all the time, okay? When I do have to give you, it's only because I have to, okay? So please, you guys got to make that effort. Those of you that are making that effort and you're doing work outside of the class when I'm asking you to do it, I know that you're going to do well when we come to the test on Thursday. But if you are not doing that, you need to get that in your head. You got to make an effort, okay? All right. Were there any questions on number one? Okay. Does anybody see anything on number one there that's important that'll help you? What do you see? Vertical angles. What do you know about vertical angles? No, vertical angles don't equal 180. They are vertical angles. What do you know about vertical angles? They both have the same measurement. So all you have to do was set up those two angles equal to each other and solve it for x. So, well, first you should be able to write 3x minus 40 equal to 2x minus 10. That should have been your first part you're setting up as I'm waiting for the screen to show it. Then you're gonna, since they're both equal to each other, then you want to solve for the variable. So your first setup should look like this. Now, for those of you that already forgot vertical angles, they're there all the time. Okay? How do I solve that for x? Subtract 2x is the better move, because that'll give you a positive 1x on the left side, and all you got to do is move all the variables to the other values to the other side now. So what would be my next move then? Okay. So all the variables are on one side, 1x. That's gone. That was moved. That gives me 30. The variable is a positive 1, right? So you basically have your variable answer there. You guys, again, solving equations is something that you guys are going to need to remember what to do there, okay? All right, everybody okay on this one? Can I move on? Yeah? All right, any other questions? Number 2, okay. Look at number 2, and you notice number 2, there's two angles that are adjacent to each other. So what do you know about adjacent angles? They have to add up to equal 180. So you're going to set up those two angles added up together to equal 180. So that should be your first clue right there. Is you can see that there's a straight line right there. Straight lines are always 180. Okay. So when you're looking at what you're going to try to set up, draw pictures or something to help you try to get the clue. This is, let's say this is angle A and this is angle B. That should be A plus B equals 180, shouldn't it? And A. Okay, that's why we went over all those linear, supplementary, complementary, vertical angles. That was the whole reason of doing all that. Okay. That's all right. Shouldn't have messed it up too much, because there's 6y minus 10 is that angle. Plus 6y plus 10 is that's why you guys take notes on all those stuff, okay? How about from there? Does that make sense? Do you notice I didn't put the parentheses there? And that's because I know this plus sign is not going to change this, any of that. If there was a minus there, that minus needs to be there because it will affect the parentheses. Can I combine any terms?
What?
6y, they're already on the same side. Those two, you just combine them. They give you 12y. These two are similar terms also. They give you 0. Yeah. If you put plus 0, that's fine. Okay. Equal to 180. That's the same as just saying 12y equals 180. How do you finish that? 12. 180 divided by 12. 12 goes into 18 ones with the remainder of 6. 12 goes into 65 times. 5 times 2 is 10. Carry over the 1. 5 times 1 is 5 plus 1 is 6 with the remainder of 0. So y is equal to 15. I know I went pretty quickly on those, but again, you guys have all of those notes. Now, let me go on this real quick. I told you guys finding unknown angles. Does everybody have that handout, finding unknown angles? You guys got to start using the information you have. Okay. So this is something that you guys got to get in the habit of doing. This is why I spent some time on some of these reviews so that you didn't forget. Okay. Okay, this is the handout I'm referring to, finding unknown angles. Everybody pull that handout out, please. Hey, did you go through that? Because I'm going to show you some things right now. We went over, we took almost an hour on this handout. Look at the vertical angles. What does it say about vertical angles? Yeah? Okay, look at this one. That's the one we just did those two. Yeah? So you guys have to be a little bit more responsible about going back and referring to these handouts. There's a reason why you guys highlighted all this, didn't you? Yeah. Inside of triangles, we went over that. I think we took 2 days on this one. I went over. I'm pretty sure I made you the second day. Go back and review and read this again. If you look at my videos. Yeah. Okay, so you guys need to be able to go back, and I gave it to you as a cheat sheet. Use it. Okay. All right. So please, you guys gotta put effort into this. You can't just. You get 11x plus 4 is equal to 180. Subtract the 4 to both sides. You get 11x is equal to 176, I believe. 176 divided by 11. 1 time 6. 6 times 6 is, oh, that's 66. And you still get x equals 16. Okay? What I just showed you was 2 different ways to solve for the same variable. Okay. Okay, there's another thing you could have done. These 2 angles that I'm coloring in green should add up also to 180. And I'm going to go back to this finding unknown angles handout. I made you guys read this very carefully, and I told you you're going to be using these. Okay? Adjacent angles. Vertical angles, yeah? Okay? All right. So in that problem right there, you could have also done that then. You could have done 180 minus 65. And that would have given you this question mark angle right there. If you get that angle, then you know 7x plus 3 is equal to that number also. That's another thing you could have done. Yeah. But remember the directions are saying find the value of the variable. Yeah. Please make sure you guys are reading the directions of the problem so that you didn't have to do anything else other than find the value of the variable. Okay? All right. And number 6 is just like numbers 3 and 4. You notice that number 6, these two angles are vertical angles to this angle right here. So 4y plus 6y should add up to equal how much? 90. 4y and 6y give you 10y? Yeah? All right. So those questions right there, please, just, you guys got to put a little bit more effort. There's a reason why, again, I had you guys, we took the time on this very carefully to make sure people understand you're going to use this, okay? All right. Numbers 1 through 6 then, I think I've answered any questions there from them. Yeah. Numbers 7, 8, 9, and 10, find the measure of the angle. So angle A is 3 times as large as its supplement. So angle A is 3 times, that means plus, minus, multiply, or divide. So which one of those 4 is that's multiplied? 3 times as large as its supplement. They have to be 180. So if you know what angle A is, 180 minus angle A. Yeah, because what if you did what is the supplement of 68, for example? What is the supplement of 68? So 68 plus what gives you 180? So just do 180 minus 68, the number that you do know. Yeah. Remember the handout we did, supplement and complement? All right. So find the measure of each angle. So angle A is 3 times as large as its supplement angle B. Just one correction. I should read angle B right this. Angle A is equal to all of that. Because it's the supplement of angle B. So angle A, this word is, means equals. Just correction right there. Find the measure of each angle, and the measure of this angle would be, we'd have to know what angle B is, and then we can finish that. So writing that out, that would be all you needed to do. We have to know one of the 2 angles in order to get the one that's missing. Notice we're not given any information on angle A or angle B. Okay. Angle A is, so angle A is, that means equals. That means what? 1/4. That's a fraction, right? 1/4 as large as its supplement. So 1/4 as large, that's a multiplication. 1/4 as large as its supplement of angle B. So that would be 90 minus angle B. Number 9, angle A is 5 times. So angle A is 5 times as large as its complement. Oops. I'll be copying on this number 8 here. It said
Supplement.
supplement, so that should be 180. Or not 90. And number 9 is complement, so that's 90 minus whatever angle B is. Angle A equals, the word is equals, 5 times means to multiply. And complement should add up to 90. If we know one of them, just take it away from 90 and we get the other one. For example, what's the complement of 68? Minus 68, so 22. Yeah. Number 10, angle A is 1/8. So that's 1/8, as large as its complement. That's 90 minus angle 50. And right here, the only thing we can do is that's as far as you can go. You don't know what angle. If you knew what angle A is, then that's fine. Or if they told you angle B, then you could finish. But other than that, you can't do anything.
So that's just minus.
That would be the answer. Yeah. Write 3 conclusions that can be drawn from each figure. So number 11, you need to remember vertical angles are in the picture. You need to remember adjacent angles. Add up to how much? 180. What can be drawn? Does everybody see this angle right here is given? Angle is, that one's 125. That means that angle is 125, which is angle OMA equals 125. Can you give me any other information? Angle PMO equals how much? 55. Okay. Can you explain to me how you get that number? All right, good. Everybody see? These two are adjacent angles. So he doesn't know. We don't know what that one is right there, right? All we got to do is 180 minus the one that we do know. I gave him the 55. Assuming that that's correct, 5 to 5 is 10. Yeah.
And then the opposite side of 125 is also.
And what letters would make up that? PMQ is also 125. What are those angles called?
Vertical.
Vertical. Everybody agree? You're only missing one angle now.
NQO.
Not NQO. We have NQO. It's the same as OMN.
So NQM.
Not NQM. You can't say that way. NMQ is how you would say it. Because if you say NQN like this, it's a different angle. Okay, so just be careful with the order how you say the letter there. Okay, because that technically I'd have to mark it wrong if in that case, because you got to make sure you're referring this one, and that one. Just make sure the middle letter should be M. Other two you can switch it. Yeah. So N, M, Q, and that one measures how much? You already know what it measures. 55. It's a vertical angle. So this one, isn't it?
Yeah.
Those are vertical angles. So you guys gotta keep in mind, vertical angles are always gonna be all over the place, okay? All right. Everybody okay right there? Vertical angles? All right. Okay. Ooh, in this picture there are some very important things that you have to watch out for. Okay, so okay, so you got a couple things here. You got this mark and this mark. What do you think they mean? What do you think of it?
Different angles.
Not different. They're the same angle measures. You just don't know what they measure. Notice it only had one like little arc, and the other also had only one little arc. Those two are congruent angles there. We just don't know how much they measure. Okay? There's something else in the picture that's important. There's a right angle. Is there? how many right angles do you see?
2.
2. Does everybody see one of them's right here? That means this one, which I don't know what it is, but whatever this one is, this one's the same. That's x plus x equals 90. Or 2x equals 90. X is equal to how much? 45. 45 plus 45 add up to 90. That little mark that you saw is a clue to tell you whatever those angles are, they measure the same. And then the other clue was that they both added up to 90. Okay. Now there is another 90-degree picture in there. Does everybody see it? You see the little, even littler box? That means this one and this one add up to 90, right? Remember all those conditional statements, if and then? If this one is 45, then this one is how much? Also 45, because they have to add up to 90. Do you see that logic puzzle, how when you end up solving it, these if and thens are going to keep coming up now? Well, if that angle is 45, then this angle has to be 45 because they both add up to equal 90. You guys see how these pictures in the drawings have more to it than just a random line coming out? Okay. So Evan, on number 13, do you notice anything?
Yeah, it said if you can turn it on.
Oh, okay. Go ahead, Evan, what do you notice? The little arches. Are they both only one arch? Each? They only both have one arch each. Do you notice that? So that means they're both then what? Congruent. They're both congruent. Now, do you notice I said they both have one arch? If they would have been written like this, 2 arches and this one only had 1, then they're not the same. Does that make sense? Yeah. So you gotta, there's a lot of symbolism going on in geometry. So you just gotta look out for those, all these little drawings is what it is. Okay? So you guys are kind of like reading hieroglyphics, sort of. Okay? Alright. So I know those 2 angles are equal to each other. Now, is it very obvious that this is a straight line? That means these 2 add up to 1 angle. I don't know anything else other than that. So the only things I can set up are angle AWB plus angle BWC add up to 180. I also know that angle BWC is equal to what letters? No, not AWB. Say it again. AWD? No, not AWD. Oh wait, AWD, you could say that. Wait up, no, I can't say AWD. Here's why. This line here actually would extend that way as a straight line.
DWC.
DWC. Those 2 angles are equal because notice they both had only 1 arch. That's all you know. Don't know anything else. All right. If they gave me a number there, that would help. But I don't have any numbers for angles, so all you can do is at least set that up and just, unless there were clues given, you know, then you could go further. Okay? Yeah, if one of them gave me a single number, then we could actually solve something else. But right there, you can't do anything other than set that up. But here's the thing, you guys got to be able to look at these pictures to set up some type of information. That's how we did those ones at the beginning, some of you guys might have struggled with it. Okay? All right. Are there any questions on that part right there? No? Okay, so you guys understand how important you're gonna need this handout to go back underneath? Okay, so that's why it's a cheat sheet for you. We highlighted everything so that you don't forget. Okay, use that. Okay, any of these cheat sheets that I'm giving you guys, don't throw them away. Okay, you guys can use them. Okay, all right. Okay, so let's go to the next part then. Is that the page that says parallel lines? Yep, all right. Let's get our highlighters. All right, so when we're highlighting things, hopefully that you're starting to get that clue. When you're highlighting stuff, this is what you need to use when you're doing work. Yeah? Okay? All right, so highlight. Now, I don't have time to review these problems, but I want you guys to please put a star there and work with the tutor on those, that you guys know how to solve those. Okay, so that's I want you to do with the tutors, okay? So you guys, so now I'm putting something on you. You need to make sure you know how to do those. And the other thing would be that you know how to do these too. Okay? Now, if you don't take the time to work with tutors with those, that's fine if you, as long as you can do them on your own though, okay? And then if you have time, remember Mondays and Wednesdays are the times I have available to work with people individually. Okay, so please, the only things I have available other than Mondays and Wednesdays are that I'm posting the videos for you. To just kind of repeat repetition for some of you is important. Okay? So I'm going to leave that for you guys, okay? All right? All right. So make sure you put in your notes, review on your own, okay? Take a look at some of these vocabulary words we're going to talk about today. So put a starter, because we're going to go over these words. Okay? Now the first word that is already set up for you is transversal. So go ahead and highlight that word, transversal. Okay? It's already there. Can you go ahead and read what it means, transversal? As I'm setting myself up. So now, keep in mind, you're highlighting things because I need you to remember, you need to go back to this part. If you get stuck with any of the problems that I might, if I don't get to them, then I'm going to leave them for you guys, okay? So a transversal is a line that intersects two coplanar lines at two distinct points. Do me a favor, underline the word with your pencil, transversal. Underline it. You highlighted it already, right? Now underline it. Okay? Alright, so here's, do you guys see the picture on the right to it? Yeah? There's three lines there, okay? Yep. One of them's labeled the letter M. What letter is this? L? L? And this one? R. Okay. One of those, T? Okay. One of those three is the transversal. Who wants to take a shot at telling me which one of those three is the transversal from this definition? So read the definition again. Okay, Brian, right? Which T? Yeah, T is the transversal. So do me a favor. Draw an arrow so that you guys clearly can tell when you guys are doing your work. Transversal. Okay, this line is a transversal. And now you got your definition there? Yeah? Okay. All right. Now, there's 8 angles are formed when two lines are intersected by a transversal. Does everybody see all the 8 angles that are formed? All right. All those 8 angles have measurements. Okay? And those measurements, you're going to have to go back and refer to vertical angles, adjacent angles, angles that are supplementary or complementary. Okay. All those things, those activities that we did with the previous stuff are all going to come up, okay? Does everybody remember how to do supplement and complement? Okay, remember all that stuff, okay? I think when we did the handout, everybody was like, "It's so easy." We went through several tables. Okay, that's fine. But again, go back to, remember, highlighting stuff, go back to check it out, okay? All right, so everybody go ahead now and highlight this next word, alternate interior angles. Now they're using two keywords there, alternating and then interior. So just do me a favor. Can everybody look up on the screen for me real quick? You guys see all the ones that are labeled 1, 2, 3, and 4, yes? Is that right? 1, 2, 3, and 4? Okay. Those are all interior angles, okay? The ones over here on the outside that are not labeled, can you tell that those would be the outsides, exteriors? Now we're not going to talk about those yet, okay? But those are the exterior ones, the ones that have the red dots on them right now. Okay. If they're alternating interiors, that means they're not right next to each other. What angles that are interior are right next to angle 1? You see 3 is right next to angle 1? And you see that 4 is right next to angle 1? Those are not alternating interior angles to angle 1. Which one is left then? 2. Angle 1 is an alternate interior to angle 2. That's already stated right here, right? What are the other pairs of alternating interior angles then? 3 and 4. So there's 2 pairs of alternating interior angles. 1 and 2 and 3 and 4. Alternating, has everybody heard that word, alternating? You're skipping? Yeah? The angles cannot be right next to each other if they're alternating. Okay? So 3 and 4. Do you notice that angle 1 and angle 3 are a linear pair? So what should angle 1 plus angle 3 add up to equal if they're a linear pair? Angle 1 plus angle 3 are a linear pair. They're also called supplementary angles. They add up to 180. Do you notice that angle 1 and angle 4 are on the same side? So now, same side, interior angles. Angle 1 and angle 4 are same side interior angles. What is the other pair that's same side interior? 3 and 2. 3 and 2. And now we've got another word, corresponding, okay? Go ahead and highlight corresponding. Now they gave you one example of corresponding angles, angle 1 and angle 7. So here's what I'd like everybody to do before you do anything else. Can you go ahead and put your pencils down? And does everybody see those 4 angles that I'm circling? Okay, imagine I cut that out and I translated it and I put it on top of these angles. Do you see that angle 1 would be on top of where angle 7 is? What would be, where would 5 go? On top of 4. So angle 5 and angle 4 are also corresponding angles. Do you see that there's 2 more pairs? What is the other pair corresponding angles? 6 and 2. And somebody said 3 and what? 8. Correct. Now, did everybody understand what I was trying to tell you? If I were to cut these 4 angles out and just put them on top of the one, just translate it to the bottom, how you figure those corresponding pieces. So you guys highlighted these 3 words, okay? So I'm going to tell you right now, we're going to look at these angles. When you get stuck, you guys got to remember, that's how we first learned these 3 words, okay? All right. Now, identifying angles, we've already identified all the other ones. We actually did all of this already, okay? Now we're going to do a couple other angles, okay? So please keep in mind, when we start doing problems, if there's some problems that I don't get to, this is the stuff that I need you to go back and reread them, okay? Go to the next page. And here is a real world example. Now, if you have trouble, this I would want you to go over with the tutor if you need extra help on that, okay? So just because of time's sake, I want to move on to the next type of angles, okay? So that one is for you to go and work with the tutor, okay? Now there's an example there for you, okay? All right, so here's where we're at. In the picture on the top, it says, the vapor trail of the high-flying aircraft suggests the transversal of the parallel trails of the low-flying aircraft. Can everybody distinguish those, the trails of vapor from the 2 aircraft? I'm pretty sure you guys at one point out here, there's always been airplanes passing by and you've seen images like that in the sky. Yeah? Yeah, almost every day. Now, can you see these 2 lines are coming from the engine of this jet or plane? If 2 lines are parallel, does anybody know what parallel lines means? Never understood. Parallel lines never intersect. No matter how far you are going to look at those lines, technically lines go forever in both directions. If they're parallel, you can go forever, but they will never touch. Okay? They'll always be the same distance apart from each other all the way through. Parallel lines don't have to be equal to each other, meaning the length of one does not have to be the length of the other line either. If they're parallel, one of them could be this long, and the other one could be this one. If we're using length, I only use points. If those lines are parallel, the image inside of it will have a set of arrows inside of it somewhere, going in the same direction. This part right here is a symbol that tells you that they're parallel. Okay? So in your notes, if you draw from A to B and C to D, this is saying that A to B is parallel to C to E. That arrows inside of the line somewhere, they have to be going in the same direction. Okay? So now, these symbol notations that you gotta look out for. Okay? Does everybody see this box right here which says postulate 3.1? Do you guys see a set of arrows in the same direction somewhere in that picture? Yeah? on T and M. You guys see that?
It's L and M.
Oh, it's L and M? Okay. So on L and M, you guys see those extra set of arrows like right here? That picture is then identifying to you that those two lines are paralleling just by the symbol notation. It doesn't have to tell you in words that they're paralleling. Okay? Now here's a definition about corresponding angles. Now, do you guys understand how we figured out corresponding angles right now? Please read this very carefully, because this is a definition that you will be needing to use, just like the same way you guys learned the definitions for vertical angles. Okay? Corresponding angles, you notice, are congruent to each other. If and only if the lines are what? If and only if two lines are parallel and they're cut by a transversal. Yeah? What if the lines are not, if two lines are not parallel and they're cut by a transversal? Are corresponding angles congruent then? No, you can't assume that they are congruent. The only way you can tell if the lines are parallel, if you look at the imagings there, if it shows you the symbols of parallel lines, or it tells you straight out in the directions that they're already parallel. Yeah? Those are the only two ways that'll identify it. Now, if you can figure out if the lines have the same slope, that's another way to figure out if they're parallel also. But we won't do that until later, okay? Because that's some algebra that you guys used to do, solving the slope dilemma. All right, does everybody understand corresponding angles are congruent only if two lines are parallel cut by transversal? All right, look at the next ones then. Alternate interiors and same side interiors. They are not the same. Highlight those words that we're going over, corresponding angles, alternate interior angles, and same side interior angles. All three of these are going to be used to help set up an equation so you guys can solve for some variable, okay? All right. Is everybody okay with those corresponding angles right now? You notice that alternate interior angles are congruent if two lines are parallel and they're cut by a transversal. Now, please put a star here on same side interior angles because those are not equal to each other. Same side interior angles are not equal to each other. You notice that they add up to 180? If two things add up to 180, that's also referred to as complement or supplement. Which would be supplements. Okay? If two things add up to 180, it's also referred to as adjacent angles or a linear pair. Okay? Does everybody understand angle 1 and angle 2 are on the same side and they're interior angles? If the lines are parallel, then those two angles add up to 180. So what I'm trying to give you guys some heads up is, these are going to be the different rules that you're going to try to use to help set up some type of an equation. Okay? So far, you guys okay? Yeah? All right. So we've got corresponding angles, alternate interior angles, same side interior angles. Please don't forget vertical angles. Does everybody remember how to identify vertical angles? Please don't forget vertical angles because those will always be somewhere in the picture. Okay? Vertical angles, don't forget. Okay? All right, so now we've got all these new definitions and new words, so that they don't feel so overwhelming, let's just practice a few, yeah? Okay? Now, two more. So go ahead and highlight alternate exteriors and same side exteriors. And put a star where same side exteriors are. Because those add up to 180. alternate exteriors are equal to each other or congruent to each other. Okay? Only if and only if. Remember when we were doing the conditional statements and I said now when you use if and only if, it's because it's true forward and backwards. If two lines are parallel and they're cut by a transversal, alternate exterior angles will always be equal to each other. Okay? And same side exterior angles add up to 180. Does everybody notice that for same side exterior angles, that angle 3 is corresponding to the angles adjacent underneath angle 2? Those are corresponding angles. And these two, do you notice they're adjacent to each other? They add up to 180. So all of the stuff that we're talking about, vertical angles, you guys are good, right? Two lines intersect, opposite angles are vertical angles. Okay? They're always equal to each other. Always. Now, the key here, do you guys notice on all of these rules, they all say lines have to be parallel and they're cut by a transversal? The transversal is the line that cuts two lines or more. It doesn't have to be just two lines, okay? It could be 3 lines, it could be 4 lines, okay? But a transversal has to cut 2 lines, okay? So now that we have these different theorems, we're going to use those, okay? Now, take a look at this example right here, example number 4. Can you guys read example number 4 to yourself? And I'm going to set myself up to do something real quick. I like this test tip right there for you guys. You guys can make marks on any diagram, either extending the lines or whatever will help you. Okay, I'm going to do that right now with this example. Okay, and the next one below it. Okay, you guys should be able to visualize things in your head and be able to draw it. Okay. All right. So take a look at this example. I'm going to open it up a little bit more. All right, now so far do you notice it said find the measure of angle 1 and then find the measure of angle 2. Which theorem or postulate justifies that answer? That's all those things we just highlighted, alternate interiors, exteriors, same side interiors, and exteriors. All those theorems and postulates that you guys just highlighted, we're going to refer back to them, okay? So if you need to, go click back the page, okay? All right. All right, so can you guys see this part right here? You notice it says A with 2 lines and then B? That means A is parallel to B, yes? Angle 1 measures 50 because corresponding angles are congruent. Do you guys agree that we had a box postulate or theorem that we went over that said if 2 lines are parallel and they're cut by a transversal, corresponding angles are congruent? You guys remember seeing something that said that? Yeah? Okay. Angle 50 is angle 50 corresponding to angle 1. Yeah? If you were to cut these 4 and put it on top of this, angle 50 would be on angle 1, wouldn't it? Yeah? Okay, so angle 1 is 50 degrees. You understand how they solved that and how they justified it, their corresponding angles? Okay. Now do this. What does that say right there? C, 2 lines D? C is parallel to D. You guys got to be able to read these symbols, okay? If C is parallel to D, now everybody find C and D on the picture. Everybody see where line C and line D are? Those 2 lines are telling you they are parallel, okay? Do you notice that these other two lines are then considered transversals? Because they cut both of those lines. And then vice versa. When A and B were parallel, these two lines were transversals of A and B. And what's going to happen is you got to learn to focus on only certain lines. Try not to focus on every single thing. Okay? So if C and D are parallel, angle 2 measures 130. So everybody look for angle 2. Angle 2. Now do you notice in the picture they only gave us one angle, and that was this one right here, which measured 50? It says angle 2 measures 130 because same side interior angles are supplementary. Is this right? That angle 50 and angle 2 are on the same side and they're interiors? Yeah. Same side interior angles have to add up to how much? 180. So if angle 2 plus 50 degrees adds up to 180 degrees, do you understand how they figured out angle 2 is 130? Take away the 50 to both sides. So, are there any questions how I figured out and just explaining those two answers that are given in that example? All right. Can everybody do me a favor? Can you try to figure out what this angle 3 measures? And just put right next to angle 3 what you think that angle measures. If you need to do any work, just do it over here on the side. And then put your pencils down. You try to figure out what angle 3 is. Put your pencils down and then just let me have your attention. That way, anybody that might be struggling, this is your opportunity to let me know or ask questions, okay? Now we're going to justify how you figured out what angle 3 measures, okay? How many guys are feeling you kind of got the hang of this? 1, 2, kind of, 3, kind of, okay, 4, 5. All right, out of you 4 that feel like you guys kind of get it, let's see, I haven't heard, right? What do you think angle 3 measures? Okay. No? Okay, Grant, what do you think? Angle 3 measures 130 is correct. Could you give me a reason from those definitions that we went over that would help explain to some of the people that don't get it why? Because your answer is correct. What do you think would justify that?
Because I just looked at angle 1.
Okay, and you already know what angle 1 is, though. It's 50. Okay, and did you relate 2 to 3 at all?
Yeah.
What are they called? What are the name of them? On the That's what I'm trying to get to. Corresponding angles. If 2 lines are parallel, cut by transversal, these are parallel also. Corresponding angles are congruent, aren't they? And we already figured out what angle 2 measured, right? It's 130. Therefore, 3 has to be 130. You notice angle 1 is 50? Then angle 3, that are both same side interiors also? Those two should add up to 180. And 50 plus 130 is 180. So your answer is correct and your reasoning is correct. Now there was a couple of you guys that didn't feel comfortable with the answer, but do you get how she explained it and how she got that number? Yeah? All right, can everybody try to get angle 4 for me real quick? And then put your pencils down. Now those 4 that got it already, let me see if I can get other people to give me some help here, yeah? So just put down what you think angle 4 is, okay? So for angle 3, those were corresponding. So for A, corresponding angles was the reason why we figured out angle 3 was 130. All right. Evan, Diana, Julie, Tatiana, and Haley. Okay, do you guys feel you understood the last one? How they got the answer of 130? And did you understand the corresponding angles for reasoning? Yeah. Okay, out of you guys, any one of you guys feel we know what angle 4 measures? No? Really? No? Daniel, no? 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 Okay. Michael, what do you think angle 4 is? 130. Angle 4 is 130 is correct. Could you give me a reason why? And you can use any of the other angles we've used already because we already have 3 measurements.
What's the vertical with angle 3?
Perfect. Angle 3 and angle 4 are vertical angles. And we already know what angle 3 measures. You see that? So remember I told you don't forget vertical angles because they're always going to be in. Now you could also say that angle 4 is an alternate interior angle to angle 2, isn't it? Is angle 4 and angle 2 alternate interiors? See, angle 4 and angle 2 are alternate interiors. Here are the 2 parallel lines. Alternate interiors. These would be the other alternate interiors. Okay. Vertical angles is correct for number 4 to justify that because it's a vertical to angle 3, and we already know what angle 3 measures. You notice you're using these if and then statements in your head just to figure it out. If I know what angle 3 is, and angle 4 measures the same because they're vertical angles. Yeah. All right, everybody try to do angle 5 for me real quick. And then put your pencils down. Now I got some of you guys are getting it. But there's some of you that I don't feel are getting this, so I need to make sure that you guys are asking questions and you're trying to figure out the answer, okay? Those of you that are getting it, you see that you already know all the angles? Yep. Okay. So that's good because you're starting to see, okay, once I know one of them, I can find the rest of them. Yeah. And you notice all these things, alternate interiors, corresponding, you're going to try to use those sometimes, okay? Now, those of you that are getting all these, go ahead and finish 6, 7, and 8 then, because you can probably get those answers fairly easy now. And just put it in your whatever your numbers are. And then we'll go over the justification in just a few seconds, okay? Now, those of you that are having a little bit of trouble, I need to get a little bit more participation from you guys, so that way I can see that you're kind of getting it at least a little bit, okay? So, 30 more seconds. Now we're going to do angle 5, okay? Now some people are already getting this down very easily, so they're already done up to angle 8, okay? Alright. Let's see. Evan, how you feel so far? We've done angle 3 and angle 4 right there. Do those make sense as we justified those? Alright. Do you feel you're getting it a little bit, or so still? Okay. How about you, Diana? You getting it, or still 50-50? More of not getting it. Not getting it yet? Okay. All right. Let me make sure I have your attention. Okay. Ladies, any of you feel like you getting it? A little bit. Okay. Any of you want to volunteer for angle 5? Julie? Correct. Everybody agree angle 5 measures 50 degrees because it's a vertical angle to angle 1, and since we know what angle 1 is already, angle 5 and angle 1 have to be equal. So the fact that she said it's 50 degrees, that is correct. And her reasoning, did everybody understand the reasoning? Yeah? Julie? angle 1 is 50. Are you doing the next angle already?
No. Okay.
Oh, okay. Oh, to get angle 5, the way you explained it, angle 5 and angle 1 are vertical angles, yeah? And since we know angle 1 is already 50, angle 5 has to equal 50, yeah? You notice that angle 5 is a corresponding angle to angle 8. So you already know what angle 8 measures. Angle 8 measures how much? 50. If the lines are parallel though, right? Are the lines parallel? Yeah, that was stated. That was good, okay? We know that angle 8 measures 50. Do you know that angle 8 and angle 7 have something that you can relate them to, angle 8 and 7? They both add up to equal 180. So if angle 8 is 50, angle 7 has to measure 130. Has to. Angle 6, do you notice that angle 6 and angle 7 are same side interior angles? And they have to add up to 180. Angle 7 measures 130. Angle 6 has to be then how much? 50. Angle 6 has to be 50. Right. Now those of you that are getting this, you see how quick you got it? Now those of you that are not getting it, okay, did you understand the reasoning that I said right now as I went through angle 6, 7, and 8? Yeah? Okay. All right. Angle 8 is 50 because it's a vertical angle. Yeah? So I would go back through that video to replay that. Okay? That's fine. All right. All right, let's move down to number 5. Now can everybody read example number 5 on their own, please? And then we're going to try to solve the problem underneath example number 5. So right now, everybody needs to focus on example number 5 and trying to solve the problem underneath it, okay? So I'll give you 2 minutes to read example number 5 and try to solve the problem underneath example number 5. We got a few more seconds, but here's a hint. You should have extended those lines. Now, in that picture, there is a clue already. Are there any parallel lines in that picture?
Yes.
Okay. These lines are my parallel lines. So I'm just going to use dotted lines. Now, they're roughly not straight, so try to make them as straight as you possibly can. Okay. I'm going to use dotted lines when I do drawing to try to remind myself. Those are parallel, not the other ones. Okay. Notice the other two that are solid, they're just transversal. There's just 2 of them. Focus on one of them. Don't focus on both of them at the same time, okay? What would these angles be called? Don't focus on the other transversal angles. They're both right angles. One of them's 90. The other one has to add up to equal 90 because those two have to add up to 180. They're called same side interior angles. So that means 2x plus that other 90 have to add up to 180. You notice when I take away the 90 to both sides, I just get 2x is equal to 90. Now, if one of them's 90 and they're same side interior angles and the lines are parallel, which we identified, they have to add up to 180. One of them's 90, the other one has to add up to 90 because 90 plus 90 is 180. So you should be able to jump to this fairly quickly. Yeah? How do you solve that? Right. Okay. x equals 45. You already know that that angle measures 90 degrees. Yeah? You just have to solve for that. What is x? So I told you, extend the lines just to help you visualize. Here's the parallels, here's the transversal. Those are called same side interior angles. Get in the habit. Those are same side interior angles. That's how I did all this. Okay, now it's your turn. Okay, somebody raise your hand. And preferably the people that are not getting this, I need you guys to give me some participation here because you really need to be able to understand this. If you're struggling, that's okay, I'll help you, okay? Those of you that are getting this is probably starting to look very simple now to you. Okay? All right, now I haven't finished the problem. I need to solve for y, okay? What do you think, Evan? Now you need to focus on this side now. Don't focus on this transversal, okay? So let me go ahead and I'll erase it real quick and then I'll put it back there. Just focus now on this transversal and these two parallel lines. What do you know about these two angles? They both add up to 180. Those are same side interior angles, yeah? All right. So by me erasing all that work, can you see it clearly like that when it's just those? Yeah? Let me put all that work back up there. There we go. Oh, wait. Okay. You won't let me take it back. All right, that's fine. Y plus y minus 50 should add up to equal how much? 180. These are called same side interior angles. That's back from when we were highlighting and reading those definitions, yes? Same side interior angles? Right. This is y minus 50. It's same as your copy. Right. Oh, okay. All right, now from here, you guys have to be able to get to this. Okay? Because at this point, solving equations is not be that difficult. If you guys are having trouble solving equations, that's a basic skill. That's something that I'm not going to go over. You guys got to go and see the tutor about solving basic equations, okay? I'm not going to spend time, how do you solve an equation? You're supposed to know that. Can I ignore the parentheses? Yeah, this plus sign isn't going to change it. Unless it would have been a +2 or something bigger, then you would have distributed, but it's really a +1. So that really means I'm just going to write it like this, just for the sake of anybody not getting this. So, all right, next step. That's 2y, this is gone now, yeah? 2y equal to 230, okay. Now I went pretty quickly on there. Now, just to let you guys know, copying down doesn't mean you're learning it. That's why I give you guys time to try to do it on your own, okay? You guys gotta get that mentality of, it's okay if you mess up. It's okay. Mess up, but try, make an effort. Because if you just wait to copy things down, you're not learning how to do it. You're just learning how to copy. And on a test, you can't copy from somebody because that's considered cheating. Okay? I don't think we're doing too much difficult stuff, but for those of you that might be struggling a little bit, do you understand? You need to really go back to the videos and replay stuff too, so that you can take your time on stuff. Okay. Right. All right. Any questions on that part right there? How I figured out what y is? Do you understand the reasoning? Those were same side interior angles. That's why they set up to add up to 180. Okay. Had they been alternate interior angles, then we would have set them equal to each other if the lines were parallel. Okay. Or if they would have been vertical angles are always equal to each other. Yeah. So now all of these terms that we've been using, the more you'll learn them more, the more you practice doing them. Okay. So when you get to, you're going to do these on your own. You're going to label what they are. Okay. You're going to find out the measures of these angles. Okay. Now, everybody go to these problems real quick. Now, I'm not going to just solve them right now. I'm just going to help you try to get an idea. On number 13, does anybody see anything important in number 13 that is going to help you? Parallel lines. Does everybody see where the parallel lines are? Okay. What do you know about these two angles? They both are same side interior angles, which add up to 180. Okay. Everybody go to number 14 real quick. Right here, when I'm circling, that's really 2x. Can you? 2x. Because notice how it's written. X, I think it's a typo because of the spacing right there. Okay. And then this one right here is just 7x, okay? What do you notice about those two angles? They're both same variables. Oops. I'll start using these terms. Start using these terms.
The alternative.
Are they alternating? They're same side interiors. They're on the same side and they're interior angles. So what do you know about same side interior angles? Add up to 188. Okay. You see number 15? Number 15 is a little bit deceiving, but focus on this line and this line. Those lines are what? Parallel. And focus on just this transversal. What do you notice about this angle and this angle? Because those are what they're referring to. No, they're not. There's nothing says it's right angles. They're corresponding angles. Yeah. Corresponding angles. Are there two lines parallel? Yes. So what do you know about corresponding angles? They're the same. That means they equal each other. Now they might measure 90, but there's no symbol in that picture that says anything is a 90-degree angle, yes? Nothing in there is saying 90 degrees yet. Okay. Now do you see how I extended the lines and just said focus on this one transversal? The other one is just to throw you off a little bit. Okay. On number 16, you can X that one out. Don't worry about 16. Okay. X out 16. All right, let's go to the next page. Now it starts to get difficult. For those of you guys that are struggling, you're really going to need to make sure you're reading and focusing on what we're doing, because now these start to get really difficult, okay?
Are these going to be on the test?
Yeah. The test is going to have more of this. More of this, okay? Meaning, whatever questions are on the test that are like this, they'll be like this, not like that. But I wanted you to do some part of this, yeah? Okay. All right. So I'm going to have to skip through that. Let's go to the next part. Pythagorean. Yeah. just focus on certain lines. Okay? All right, can everybody go to the next part just because I'm running out of time here?
Oh.
Highlight Pythagorean theorem and its converse. Now, how many of you guys have ever used the Pythagorean theorem before? Okay, good. This should be super easy now. Okay? Now, those of you that have not used the Pythagorean theorem, it's not a difficult theorem. Just watch how I explain, okay? All right, so check the skills you will need. This is for you to figure out and do on your own. Square the lengths of the sides of each triangle, and what do you notice? So I want you to do that on your own, okay, because I'm not going to have time to go over that part. All right. Let's go ahead and scroll down then to the Pythagorean theorem. All right. Pythagorean theorem. Highlight the Pythagorean theorem. Okay. Now, those of you guys that have seen this before, just keep in mind one thing. Whenever you're using the Pythagorean theorem, you have to make sure you're using it with the right triangle. Okay? If there isn't a 90-degree angle in that triangle, you can't assume that you're going to use the Pythagorean theorem. The Pythagorean theorem is to help you find, out of the three sides, you'll know two of them. You'll find the one that's missing, if you know two out of the three sides, okay? Now, here's what's really, I've seen students make substitutions incorrectly because of this simple little thing. Everybody see where the 90-degree angle is in the triangle? Can you do me a favor, draw an arrow from the right angle to the side opposite to it? That side is always going to be labeled your C. Does anybody remember the name of that? Starts with an H. H-Y? Yes. That's called your hypotenuse. That side is always opposite the 90-degree angle. Now, does everybody understand that little box right there is representing a 90-degree angle? Yep. Okay. The other two sides that are left over, those are called your, anybody remember? Circle it out. They're your legs. Yep, says it on the side. Those sides are going to be substituted for A or B. It doesn't matter which one you plug in for which, okay? Those go in for A or B. If you plug in C, where A and B is, that's where you're going to mess up. Always plug in the hypotenuse for C in this formula, okay? If you do that correctly, then I think everything else should fall into place very easily, okay? All right. So now, you've got the Pythagorean theorem, you've got your legs, you've got your hypotenuse. If something is a Pythagorean triple, they'll give you three numbers. The biggest number should always be your C, your hypotenuse. The C value is always the biggest number out of the three numbers that are given. So what number is the biggest out of 3, 4, and 5? 5. Okay, I'm worried some of you guys didn't respond. So I'm like, wow, some people don't know what's bigger, 3, 4, or 5? Or maybe that was just a delay in thought. Yeah, okay. What number is bigger, 5, 12, or 13? 13, okay. 8, 15, and 17? Okay. 7, 25. All right, those would be your C values. The other two would be your A and your B. Plug them into the Pythagorean theorem, and if you get the same thing equal to the same thing, then they're called Pythagorean triples. Okay? Now, I'm going to have you can go over that with the tutors, okay? It doesn't matter. These two can be A or B. C has to be the biggest one. Okay, notice the Pythagorean theorem, c is by itself squared on the other side, and the 2 are squared and then added. Okay? Alright. So that part, I'm going to leave that for you guys with the tutor, okay? Alright, let's go down to the nitty-gritty of this Pythagorean theorem. Here are 2 examples that I'm going to show you that I want you to read on your own. But I'll just briefly talk about this example number 1. Do you notice that we're not given that side right there? Oh, yeah. We're on the next page. That is a question mark. I don't know what it measures. The figure is a 90-degree triangle. Notice that that is opposite the 90-degree angle. That's what is your C value. You don't know what it is. The other 2 can go for A or B. Doesn't matter which one you pull in. So when you read this example, it's really important that you understand C always has to be opposite the 90. Notice I put a question mark. It's because I don't know what that side measures. When I solve for C, everybody see this part right here where it says 841 is equal to C squared? Yeah. To get from that to this answer, what's the opposite of adding when you're solving an equation? Subtracting, right? And then these are vice versa of each other, inverses of each other. Opposite of dividing is to multiply, right? Well, what's the opposite of squaring something? Square root. Square root of squaring something cancels each other out. And you're just left with the term. So when you get x squared equal to something, you got to find the square root of both sides. Square root of x squared is x. Square root of 9 is 3. Okay? Alright. Alright, let's move down over here now. Now there's a couple of you guys, I'm noticing you're not paying attention, and I'm noticing you're the ones that are not understanding this. Okay? Alright? Some of you, I didn't say all of you. Alright, so for number 1, the Pythagorean theorem says a squared plus b squared equals c squared. I would write that there. Alright? What did I just stress out to you guys to not mess up on? To C. So what should you do so you don't mess up? Figure out the 90-degree angle. Draw a line from that angle to the side opposite to it. That is your C value. The other 2, doesn't matter where you plug them in for A or B. Doesn't matter, okay? That means you got to plug in 10 for C. X and 7 can go either way, A or B, okay? I'm just going to put x squared plus 7 squared equals 10 squared. This part right here is I think the biggest part people have trouble is, do you understand how I substituted those values of the triangle? And remember the key, don't mess up the C value. Because if you get that one right, the other 2 will be good. Now, x squared, I don't know what it is yet. What's 7 squared? 49, okay, good. So you understand where I'm getting 49 from, right? Equals how much? 100, all right. Before I do anything, I might have gone too fast for something. If I did, can you stop me? We're good? Okay. X squared plus 49 equals 100. What's next? All right, good. We're trying to get x squared by itself. Remember when you're solving equations, get the variable alone. That's x squared equal to, somebody do some math here. What's 100 minus 49? 51? All right, now, when you get to this step, this is when you have to do the square root. Square root of x squared is x. And square root of 51, let me show you on the calculator.
You do a hockey stick.
Where's my calculator? There it is. Alright. Oh, I have to put my word. Did I not just write it?
Yeah.
Alright, that's fine. You guys know I wrote it. Okay. Square root of 51. Now this calculator, most of you guys won't start using this calculator till later on. I'm trying to find. Okay, here's the square root now. Why is it not there? Oh, there it is. Okay, there's the square root right there. See it? 51 goes inside. That's all I needed to do. Now on the, remember you guys are geometry, so you guys always can come and grab one of these calculators, okay, whenever class starts. Okay. Please grab it, and when you're done, put it back. I try to keep things nice and organized because you notice I have another class right after each other, and I'm trying to, when they come in, I don't want it to be messy. Same thing for you guys. I don't want things to be messy when you come in. Okay. Use this to just double check that your additions and subtractions are going correctly. Don't use this as a crutch that that's where all your work is. I need you to write this stuff out, okay? Right. Square root of 51 is about 7.14 approximately.
Yeah.
Okay? So now I'm going to show you another way to write square root. 51 raised to the 1/2 power. Now, I typed in square root of 51, and you clearly saw that it's that number, right?
Yeah.
This to the that power should give me that exact same number then. Right? Right, so here's what I want to explain to you guys. The opposite of raising something to the second power is to raise it to the 1/2 power. What's 2 times 1/2? 2 over 1 times 1 over 2 is 2 over 2, isn't it? But 2 over 2 simplifies to be 1. That's why when you square root something that's squared, it gives you x to the first power. But you don't need to put the 1 there. Okay? So really, raising something to, or doing the square root of something is the same as raising it to the 1/2 power. Squaring something is raising it to the second power, right? If I multiply those two together, do you notice they simplify to give you a 1? 2 times 1 over 2 is the same as 2 over 1 times 1 over 2, which is 2 over 2. 2 over 2 simplifies to be 1. Okay? As long as you remember square root and squaring, that's how you finish the problem. Yeah? Okay. So the approximate answer for that problem right there is about 7.14, you would say, for x. Okay? All right. I'm kind of running out of time here. When you go back to watch these videos, make sure you look at the dates for the video. Okay. For example, this is the video logic puzzle. That's for the quiz we're going to take on Thursday. Okay. That's algebra 2, so don't watch algebra 2 still. September 2, that's geometry. Okay. And the stuff for unit 1 are August 24th geometry. I think that was the only video I put up. Oh no, August 27th. Those two will be the ones that we got. Okay.